In this video, I'm going to do a review of inverse functions. Now, if you'll remember, a function is a rule for computing an output value from an input value. As an example, I'm going to use a linear function, f of x equals 3x plus 4. And if I use as input, say, 10, I can apply f to the number 10 or plug in 10 for x, and that means to calculate 3 times x plus 4 using x equal 10. And with a little bit of arithmetic here, that's 34, and so that is the output. And for each input number, you get an output number. The inverse of a function f is a function which I'm going to call f with a little inv up at the top. There are other notations for this, but this is what I'm going to use in this video. The inverse of a function is another function, f inverse, such that for each pair of numbers x and y, where y is equal to f of x, it is true that x is equal to f inverse of y. So what that means is that f undoes f inverse, and f inverse undoes f. So if I go back to my example, f of x equals 3x plus 4, how to calculate the inverse function? Okay, I'm going to set y equal to 3x plus 4 and now solve for x. Okay, so I'm going to subtract the 4 from both sides. It gives me y minus 4 equals 3x. Then divide by 3 on both sides, and that gives me y minus 4 all over 3 equals x. So f inverse, and I'll use y as the input parameter to f inverse. This is y minus 4 over 3. And as an example, remember f of 10 was 34. Well, f inverse of 34 is, well, 34 minus 4 over 3. I'm going to use this formula with y equal to this 34. And when you do out the arithmetic, well, 34 minus 4 is 30. Then divide by 3, and you get 10. So you can see that 10, 34 is a point on the graph of f. And from this equation, 34, 10 is a point on the graph of f inverse. An important thing to know is that you can use inverse functions to solve equations. So here's an example. Suppose that I know that f of 3t is equal to 6, and I want to solve for t. I have the same f in mind that I was using before. So this is still f of x equals 3x plus 4. Well, one option, which I'll do first, one option is to use the definition of f. So f of the number 3t is 3 times the number 3t plus 4 equal to 6. And we can solve this way. That gives us 9t plus 4 equals 6. I'll subtract the 4 over. That gives me 9t equals 2. And now divide by 9, and that leaves me with t equals 2/9. Okay. Another option is to start with the equation f of 3t equals 6, and notice that the outermost operation on the left is the application of the function f to the number 3t. Well, let's apply f inverse to both sides. Okay, so f inverse of f of 3t equals f inverse of 6. F inverse undoes f. So the left-hand side simplifies down to just 3t. Okay, did you catch that? F inverse applied to f of a number simplifies. The reason for this is that this calculation means to start with 3t, apply f to it, but to then undo the f that we just did to it. F inverse is the undo of f. But if we're going to apply a function to one side of an equation, we should apply it to the second half of the equation, the other side, so that we get a new equation. And that's what I've done here. So you can see I've applied f inverse to both sides. Just so that we're clear, I have not multiplied. Okay, this is not multiplication by f inverse. Unfortunately, our mathematical notation makes that mistake understandable. Instead, what we have done is to apply the function f inverse. Oh, and there I am. I used the other notation. Sorry, let me fix that. I applied f inverse to both sides. I did not multiply both sides by f inverse. That's a key distinction. Now, I can divide by 3 on both sides and get that t is f inverse of 6 divided by 3. Now notice, in writing this, I have to divide the result of f inverse of 6 by 3. Let me show you here. I am specifically not doing this. That is not correct because that looks like multiplication. F inverse is a function applied to 6. I also can't do this because the order of operations says what's supposed to happen is that I apply the function f inverse to the number 6, and only after I've done that do I do the division. Unfortunately, the usual acronym PEMDAS does not include function application. That really goes up here. function application. So what this means is that when we look at t equal to f inverse of 6 divided by 3, we should use the definition of f inverse. Okay, well, f inverse of y, I'll get it from a few screens up. Where did it go? There it is. So there's the definition of f inverse, y minus 4 over 3, y minus 4 all over 3. And I need to apply that to this number 6. And the result, 6 minus 4 over 3, is 2/3. So that takes me down here to t equals 2/3 over 3. I'm going to rewrite division by 3 as multiplication by 1/3. That's just a property of fractions, and that again takes me to t equals 2/9. So the lesson here is that f inverse is a function. You can apply it to both sides of an equation and get another equation, and that f inverse undoes f. Now, for a linear function, this is kind of overkill, but you have seen inverse functions already. So here we go. Square root is the inverse, well, more or less, of, and I'm going to call this s of x equals x squared, the squaring function. And you know this already because if you had, for example, x plus 3 squared equals 9, you could take the square root of both sides. That's applying the square root function to both sides. The reason I say more or less is that there's this complication of plus and minus square roots. What's happened there can be seen on the graph of the squaring function. So let me show you this. So here's x, y, and I'll draw like this. Y equals x squared. In general, f inverse of y should be the solution to f of x equals y. The problem with the squaring function is that for each value of y, there are two solutions. So for the square root, we've defined the square root. We've defined the square root to be the principal solution to, and let me put this here, square root of y to x squared equals y. That is the positive 1 or 0. So that is the notation there. So this is where square roots come from. They are the inverse function of squaring, but there is this complication that you have a plus or minus going on. So in other words, you have seen inverse functions and you've been using them quite a bit. It's just that normally we have to deal with special cases like square roots, and we don't think as much in terms of inverse functions. In some coming coming up material, we will need to think about inverse functions, and we will need to have this definition handy. And the reason for that is that we'll be dealing with functions that can't be defined any other way. The square root is already sort of like that. The square root is just defined to be the principal solution to x squared equals y. And the calculators and other instruments have ways of computing that. We're going to be dealing with other functions, in particular the logarithm, that are defined as the inverse of some other function. Now, how do you go from the graph of f to the graph of f inverse? I've hinted at this already. Let me scroll back up to it. So this was back when we were looking at the linear function f of x equals 3x plus 4, and its inverse, f inverse of y, equals y minus 4 over 3. And I pointed out that from this equation, we get the result that 10, 34 is a point on the graph of f, because when you plug 10 as an input into f, the output is 34. When you plug 34 into the inverse function, the output is 10, which means that 34, 10 is a point on the graph of f inverse. This is true in general. If you plug a number into f and get an output, you can swap the order of the ordered pair to get a point on the graph of f inverse. So, as an example, I'm going to take just the positive part of this here. This is y equals x squared. Now, to do that switcheroo visually, what you have to imagine is, let's swap the roles of the axis so that the horizontal axis becomes the vertical axis, and the vertical axis becomes the horizontal axis, and that means that the graph is going to be flipped over. Okay, so what does that look like in the case of squaring? This is now, let me leave the axes labeled flipped like this. This is x equals square root y. Let me do it like this, x equals square root y. And I drew this by just looking at this shape and drawing its flipped image. So I just flipped it over that midline right there, and that's where this came from. And normally we think of the horizontal axis as x and the vertical axis as y, so I'm going to just swap the symbols there and redraw the graph. So I have gone from the graph of the squaring function to the graph of its inverse visually by interchanging the roles of the axes and by flipping the graph over a mirror line at 45 degrees between the axes. Okay, so there you go. Quick review of inverse functions.